Hello everyone. So today we are going to talk about a completely different topic, and that is how to write Java programs in your computer. So we'll be using the BlueJ IDE to write the Java programs. So today I will make you understand how to download BlueJ, how to install BlueJ in your computer, how to write programs, run and get the output. So let us start quickly. So first, I will tell you how to download BlueJ. So go to your Google Chrome or any web browser you have, and in the address bar, type dibyaclasses.com, that is our website. In the website, in the first page of the website only, you will see that here download BlueJ is written. The red button you are seeing, download BlueJ is written. Click on that. When you click on that, it will ask you to download. Just click save and see it is downloading. So it will take time according to your internet speed. Okay. And remember, BlueJ will not work in your mobile phone. It will work only in your computer. So you have to download BlueJ in your computer, not in your mobile phone. Okay, it is not going to work in your mobile phone. So let us see what to do after downloading BlueJ. So after downloading, double click on the file and this window will pop up. Click next, again click next. Don't change anything, click next and click install. So it is very easy to install. Okay, you just have to click next and finally click the install button and wait for some time. See, completed the BlueJ setup. Okay, then click finish. Now you will see a BlueJ icon will be there on your desktop. Double click it. So this will be your BlueJ platform. Okay. So first what you have to do, you have to go to project and you can see new project. You have to click on new project. This is for the first time only. After that, you don't need to do this step. Okay. Click on new project. Okay, and give a project name. For example, I am giving the project name as Dibya classes. Then click on create. So this is how it will look after installing BlueJ. And here we are going to write our programs. So how to write programs? To write a program, you have to click on new class. And you have to give a class name. That is the class name of your program that you have written in your copy. Always first write the program in your copy, then type it in your BlueJ to check if your answer is correct or not, to check if your program is correct or not. So let us give a class name as Dibya classes. Okay, you can see this yellow box. This is a class. Okay, this is a program actually. Double click it, delete everything, select everything and delete. And here we will write the program. For example, I will write a program to add two integer numbers. The class name is Dibya classes. Then we have the public void dnm, that is a function name. And what we'll do? We'll add two numbers. Therefore, we need two numbers. Let us add two integer numbers. int, int b are two integer numbers. I've taken a variable c so that I can add a and b and store the value, and finally I will print it. We have already done this program in our previous class. Done. Now after writing the program, you also have to write comments. Okay. And you have to write at least 4 comments in your board exam. Two integer numbers. Okay. So after writing the programs and comments, compile, click the compile button, this one. It will show no syntax error. If errors are there, it will show that there are errors and you have to rectify it. Then click close. Then right click on this yellow box. Okay, right click, not left click, right click. Then click on new. Then click OK. Again right click and then click this void. Now it will ask for input, the parameter input. Give some value, 5, 10 for example. Click OK. and now you will get the output. This is how to run a program in BlueJ. Clear? So whatever programs that will be given now as assignment, so after writing in your copy, write the program in this BlueJ platform, compile it, run it, and see the result. The result will tell you that if you have done your program correct or not. For example, 5 plus 10, it will give 15. And except 15, it is giving you 17. That means you have written your program wrong. Okay, this is how to check program using BlueJ and how to write programs in BlueJ. Okay, this is your practical. You can check all your answers practically in your home. So now, for example, you want to write another class. Okay, so you don't have to click here and edit this. No. Again, click new class. Let us give the class name as Dibya classes 2. Okay, so again, delete everything, write the program here, compile it, close it, and then run the program as I did in the previous case. Similarly, you can create thousands of classes in the BlueJ platform. Infinite number of, you can say infinite number of. You don't have to delete what you have already written. Okay, you can keep all the programs on 9 and 10 in your BlueJ. You need not worry. Okay, everything will be present there. So this video was how to download BlueJ from my website, install it, how to create projects, how to create class and write programs, run it and get the output. So from now on, whatever assignment will be given based on programs, you have to write both in your copy and in your BlueJ. Write in your copy, take the photocopies, and also write in your computer and take the photo. You can take the photo from your phone also. Okay, just click the photo on your phone, and you have to give both in form of writing and also in form of BlueJ. Okay, you have to write programs in both the platform. That is your note copy, that is one platform, and the second platform is the BlueJ platform, that is in the computer. For all the assignments you will be getting in the future classes. Now I will take a leave from you. Thank you.
Java, the language some people love, some people hate, and some love to hate. Over 20 years since its introduction, it's risen to be one of the most popular programming languages in current use, provided you download the latest updates. But would you believe it if I were to tell you that this omnipresent language, the one that powers everything from apps on your phone to machines on other planets, arose from a need to build a better TV remote? Perhaps the best place to start is just explaining what exactly Java is. It goes a little something like this. Computers, at their core, only process commands in a program in what's known as machine code. Basically, a number is associated with a function, and when that number is put into the CPU does that operation. Most of these operations are simple, like adding two numbers together or saving data to memory. Now, of course, you could write programs for the processor using just machine code. In fact, in the early days, that's what people would do. The problem was that writing code as a series of numbers for simple operations was not only unintuitive, requiring an intimate knowledge of the hardware, but it was also really tedious for writing anything other than small programs, since every function would need to be built from the ground up. And as a result of this, it was highly prone to error. The solution from very early on was to write a program called a compiler, which could generate the appropriate machine code from a more English-like language. Some compilers just assigned words for each of the machine code functions, so programmers wouldn't need to remember their specific numerical codes. However, more advanced compilers began to include more advanced compound functions into their keywords, forming some of the modern languages used today, like C++. There is a catch with compiled languages, though. You can't take code compiled for one processor and run it on a different one. There is no universal standard for how CPU instructions are laid out, meaning that a program compiled for an Intel processor wouldn't work on a PowerPC processor, nor would something written for ARM run on a 6502. Java offers a solution for this through a program called the JVM, or Java Virtual Machine. The JVM acts like a processor designed specifically to run Java bytecode, while sitting on top of all sorts of different processors. That way, even though the processors on two computers are different, they can both run the same programs. The funny thing is, you'd think Java was developed specifically for this purpose, but in actuality it was just an afterthought from another project going on at Sun Microsystems. Sun Microsystems was a company that had it big in the 80s with their high-end workstations. However, going into the 90s, focus began to shift in the direction of producing servers for the newly born web. With their success, Sun pulled a Xerox and in 1990 set up a team of 13 people with the goal of finding what they believed to be the next wave in computing. The Green Team, as it was called, focused primarily on implementing computers into other consumer devices. Very quickly after starting, they moved to a separate office and over the course of 18 months created a 5-inch tablet called the Star 7. The Star 7 had everything in terms of hardware. A 16-bit color touchscreen display, PCMCIA card slots, wireless networking, and more. Naturally, matching the team's vision of computer integration and appliances, a system of different wirelessly communicating devices, specifically television equipment, was produced, with the Star 7 acting as the heart. The Star 7 also acted as a remote control, with a graphical touchscreen interface that even included an agent character. The neat trick that allowed the Star 7 to work with so many devices was a new language written for it by James Gosling, called Oak, named after a tree outside his office window. With a workable demo for their device, the Green Team moved to a larger office and became First Person, intent on becoming the underlying technology for set-top boxes and video-on-demand services. In response to Time Warner Cable's request for proposals for interactive television systems, First Person created the concept of a network for cable television that would allow individual users to write and read data into the system. Being 1992 though, the idea was just too early. Time Warner opted for the proposal from SGI instead. What First Person had developed was incredible, but without a market, their new computing concept was destined to collect dust and be written up as a loss. The team had a meeting where they, and I quote, had to figure out what to do with this technology or what to do with our lives. But after a few days of consideration, the team came to a realization, actually a pretty common one for tech companies during the 90s. Why not the internet? And you know what? It wasn't that bad of an idea. The entire concept of the Star 7 system was to build a network centered around multimedia, and as web browsers continued to evolve, the World Wide Web itself was beginning to become a network centered around multimedia, with formatted text, pictures, sound, and eventually even video. Why not add interactive content to the list? The real genius of this idea, though, is that Oak had already solved the largest problem with this plan. Normally, since the internet is populated with computers of all sorts of different architectures, operating systems, and browsers, any web-based program would need to be released in different versions to support all of them, lest it be inaccessible to certain people. With Oak, though, the website would only need to include one version of the program, and as long as you used a browser that supported Oak, you could run the program. And so, in 1994, the team got to work on making their own Oak-based browser called WebRunner. Well, actually, they didn't call it Oak anymore, since the name was already taken by Oak Technologies. So after the lengthy process of trying to find a name that sounded inviting, didn't reference the web or net, and was easy to say and spell, the team finally settled on Java. Actually, legend has it that the name Java was originally proposed by engineer Chris Worth, who read it off his cup of Pete's Java while trying to recover from a hacking marathon session while writing the WebRunner browser. WebRunner, soon renamed to Hot Java so as to match the caffeinated language it was written on, was an entire Mosaic clone, with the added bonus of being able to run little Java programs embedded in a page called applets. The next year, John Gage caught Gosling by surprise. Gage had been invited to present at the TED6 talk in Monterey to a group of entertainment and internet professionals, and wanted to demonstrate the not yet finished Hot Java browser. Panic ensued over the still rough program crashing at its first public demonstration, but fortunately that wasn't the case. At first, the audience appeared to have little interest in watching a clone of an existing browser, but the moment that something in the browser window moved, Gage had everyone's attention. You have to remember that at the time the web was nothing but static pages of static images, and to see something even as simple as lines moving and automatically sorting themselves right in a browser window was unheard of. The demo worked flawlessly, and the crowd's applause indicated that Java hype was sure to grow. After a few private demos, Java was ready to be released to the world, and in March of 1995, the team set up a public download. They watched as the number of downloads increased from single digits to a few dozens. James Gosling had set the threshold for success at 10,000 downloads, and within a few months, sooner than anyone had expected it, download 10,000 had happened. Thanks in part to being a front-page news story, the popularity of Java was growing so large that the team was constantly scrambling for more bandwidth to handle the number of downloads they needed to serve. The moment the Java team knew they had made it, though, was at that year's Sun World Conference. Java had been chosen as an item to mention in the keynote speech, but what few had known was that Mark Andreessen, the creator of the Mosaic browser and founder of Netscape, had agreed to incorporate Java technology into Netscape Navigator. Andreessen walking on the stage was a surprise for nearly everyone in the room, but for Java, now with the backing of the world's most popular browser, one with a history of establishing standards, the future looked bright. Since that day, the JVM has been ported to billions of devices, from tiny little rings given out at the Java 1 conference in 1998, to the 2 Mars rovers Spirit and Opportunity in 2004. The same language that let the world watch Garry Kasparov loose to Deep Blue live in their web browser powers enterprise servers and mobile phones alike. Yes, it seems that the write once, run anywhere philosophy of Java has grown to mean literally anywhere. But wait, I hear you cry. This video is called The Rise and Fall of Java. If Java is still really used in all those things, and still ranks as one of the most popular programming languages in the world, is it really fallen? To that I answer, no, not in the slightest. Well, actually no for pretty much all areas, except for the platform that brought it notoriety to begin with, the internet. Ironically enough, Java on the web is basically dead, with the most popular browsers no longer supporting it, in favor of a different little language called JavaScript. JavaScript. Isn't that the same as Java though? Despite the fact that an effort was made to make the syntax look similar between the two languages, both are fundamentally different under the hood. JavaScript harkens all the way back to 1995, the same year that Mark Andreessen of Netscape had officially announced the browser's support of Java. The original idea was to create a companion scripting language, named Mocha, to continue the whole coffee thing, that would work alongside Java applets. JavaScript was intended to be an easier-to-learn scripting language for simple interactivity in a web browser, while Java was intended to be the professional language for larger development projects. As it turned out though, between the numerous security flaws in Java with patching coming too little too late, and the relative ease of development in JavaScript, after a bumpy road with competing standards and implementations of the language, JavaScript would end up gaining greater functionality to the point where it was able to supplant Java entirely. Java may not exist on the web anymore, but if it's still the top-ranked language in the world, then it must be somewhere, right? Look no further than the nearest Android device. Unlike iPhones, which are produced solely by Apple, devices from all sorts of different companies running on all sorts of different hardware run Android, making Java, with its write once run anywhere philosophy, a perfect candidate for writing apps. Java can also be found in plenty of professional and enterprise applications simply for its speed and the number of people who know it. Popularity-wise, Java may have seen some better days, and despite some valid criticisms, it's not likely to be going anywhere. Java may not run the web anymore like it once did, but it certainly hasn't died like Flash has either. The story of Java is one of resilience and adaptability. The same language originally designed to build a better TV remote managed to evolve into the one that brought interactive content to the web, and when weeded out of that space, moved on to be the basis for nearly every app available today. If that's not adaptability, I don't know what is.